Hi, and welcome back to my recording of how I'm building my InMoov robot named Ralph. And I finally have some progress on the actual robot I can show. So I thought I'd give an update. Today I'm going to show you some details about my right hand, wrist, and forearm assembly. I'm not going to go into the details of how I glued it all together and did all that. That's all explained in the tutorials. So I'm just going to go over what I found unique, different, or had trouble with. I would recommend that you don't just watch my video, but you watch as many videos as you can about the construction of this robot. Everybody has something of value in their little video that you can learn from. So I'm hoping that's the case here today too. So let me shrink my picture down and get us started. Set myself down here in the corner. And we'll start out, of course, from the home page. I like to kind of take you back there so that you know where I get all this basic information from. And so on the home page of InMoov, go to build yours, build your index, and here you can see here's the hand and forearm. This is the tutorial that I followed. So clicking on that, let it load up, and it gives you what parts you need to print and where you can go to download them. Okay, and of course to download, I grabbed them right here off the galleries. Right, the STL parts library right here is where I got all the print files from, with the exception of one, which I'll point out as we go through. So I went down through here and I pretty much followed step by step what he did. So I'm not going to beat that horse to death. You can look this up and you can browse all these settings as you go. I will point out here that the nuts and the bolts, I had some luck. Some fit well, others, like he said, they didn't fit so well. But I put mine in by passing a screw through and drawing the nut in with the screw. It also helped if your hole was a little lopsided like mine tend to be. I have a problem with trying to hold everything vertical and drill. It seems like I always get everything off at an angle. So if you're like me, pass that screw through, run that nut up, and then it seats itself in such a way that you know your screw is going to start. Came on down here. I have a few details about how these springs worked. I'll pick up some detail on that. And setting the motors. I didn't use his pulley assemblies. I used a modification off of Thingiverse. So we'll talk more about that as I get into my sections. I'm scrolling down through here at a pretty fast clip because I just want to point out a couple of things down here at the bottom that I found interesting. Right here, okay, he has you start building the finger, which is fine. An assembly of the hand, and he passes through the strings. Oh, come on. Boy, I didn't realize it was this far down. Let me speed this up a little bit. Now I think we're getting close. Yeah. See here, he has you build the hand and pass the strings through and everything. And he has you go ahead and begin putting fingertips on. And getting all that done, I would recommend that you don't do that in that order. I recommend that you stop right about this point here. Well, not even that point, because it's got the tips on. And stop right here. See where you get your wires through and you get your strings in and cut. Stop there and then test things, because once you go past that, once you start gluing these pieces on here, if something's not working right, you're stuck. You can't move those strings around anymore. So that's the major thing that I would recommend that you look at. I would stop right in at this point where you're starting to glue those new sensors on, and I would jump all the way down to the bottom here. Well, not quite that far down, that's the comments. Come on, where's, here they are. I would jump down here to this tensioning of the liners, and I would stop and I'd go jump to this and look at setting your strings and making sure your servos all work. So that's the point where I'm at. Okay, so let's move forward now, and let's see how I've got things working. All right, let's watch this little video. Okay, so you see I've got things working. I've got things checked out. That's where I told you I stopped when I got the strings in, got the knots tied on the end. Then I started tensioning my strings and getting everything set up and ready to go. Let's talk a little bit about what I've got going on inside here. But before we do, let me back up to this video for just a second. You probably heard feedback of all the servos sitting there clicking and humming and everything. I expected that. That will all be taken care of when I get into my robot lab. Right now I'm just running this through an Uno card with direct code. So all that noise, I'll go into my robot lab and I'll use the minimum and the maximum settings, and I'll adjust those servo movements so that the servos aren't sitting there constantly pulling against that string. They stop and they're silent. Just wanted to point that out. Now, in here, you'll see that I've set into spring assemblies, you know, for this spring assembly is supposed to be for when you twist a wrist. It's supposed to help keep your strings tensioned. So I made mine and I put it in. I wasn't sure if I was going to use it or not, but I put it in place. At this point I didn't have my Teflon yet. Later, of course, I did get the Teflon and put the Teflon tubing pieces in, so that the string was passing through the tubing and not directly on the spring. I just wanted to point that out. And then up here, when I made the wrist, this is where I said watching other videos can be helpful. I watched a guy making his wrist and putting it all together, and he had to put it together, take it apart, put it together and take it apart several times. And that's because right here he had a mounting screw, and when he tried to put this wrist cover on, it was hitting and it didn't have enough clearance. So he went in and he filed the head of that screw down. right? And got that to work. And then when he passed the gear again through the cover plate, the screw was hitting on the wrist assembly, and he had to take it apart, file the head down, and do all that. Well, I kept that in mind when I was doing mine, and I actually discovered that when you set this servo in, you set it down in a very tight pocket. I even had to file mine just a little bit in a couple of spots to get that servo to sit down like it should. There's no way that servo motor is going anywhere. When you put that cap down, you're putting that cap right down on this. This is also passing through the cap. That servo is not going to lift out of that pocket. I didn't even bother to put a screw in. I left all the screws out. And when I put the cap on, I didn't put a screw right here to lock that gear onto that servo shaft. Actually, there's no need to. This acts as a bearing or a bushing as it passes through. The top end of that gear, that gear is not coming up out of that seat with this cap holding it in place. So again, I didn't bother to even put a screw in it. And that eliminated the hassle of having to file that screw down to get clearance and stuff. So you might keep that in mind. Let me back up here just for a second. This is what I'm talking about for the clearance. See, here's where that screw, sometimes where there's not enough clearance and you had to file it down, I left that screw out. Okay, and then this portion of the wrist, as it rotates, the gear housing sits in there. The small gear sits in there, and as that rotates, it hits, and you just don't have the clearance. So he kept filing that screw down. I just left mine off, and then I didn't have any problem. Let's move forward again, and we'll pick up. I'll pick up a few more details about this alignment piece here that sits on top of the servo motor. I'll pick up a little more detail on that in the coming slides. Just want to point it out here. And we'll go back here and talk a little bit more about the spring assembly. When I started putting these springs into the holder, I had a problem in that once I set them in down here, right, you drop them down that notch and you just pop them in here, and you know, they're supposed to stay. Well, as you work with it and play with it, they pop back out. They were, becoming a nuisance and an annoyance type situation. So I modified this plate just a little bit. After I put the springs in, then I took a piece of stock, plastic stock. This is 10 thousandths plastic stock, and I just used a little acetone, and I welded that piece over the slot. That way those springs could not pop back out. And that stopped that annoying problem of my springs popping and coming out of place. And as you can see here, I also did it on the top layer, right? These popped in from the leading edge, they pop in, and then they pop back, right back out of that hole again. So I just took a piece of 10 thousandths and a little acetone, and I glued a little plate there, and prevented it from jumping out. But as you can see, well, you can't see it now, I'm sorry. I thought I had it in that picture, but I don't. When I started playing around with my strings and tensioning them, these spring assemblies, they were crowded, they were annoying, they bent at different angles. I just didn't like it. Right? So I took that plate out. I'm not going to use it. And there's another reason I'm thinking I can get away with taking that out, is because of the gear assembly that I used. Let me go back. Well, where'd my gear assembly go? It'll pop up. We'll pick that up when I find that picture as it pops back up. I was telling you about this alignment plate. It comes with 2 holes, and when you set that down on top of that servo, it looks like, hey, I can just pass screws through here to my servo and screw them all as a unit right down into the wrist assembly. So I tried that. Well, I really don't think it was my printer alignment, but it could have been. This piece didn't fit well. When I did that, it cocked at an angle and didn't sit right, and it was just a problem for me. So I took those screws back out, and I screwed the servo down right here, independent from this piece. Then in his tutorial, it was a little older than this assembly, I guess. He changed it, and he said that what he did was he used a hot glue gun and hot glued this into place. Well, I ended up having to go in here and cut a little bit on this piece to get it that shoulder out of the way so that it would sit flat in a line laying on top of that servo. It had to align over here on this curvature on this end, and then it had to clear this servo mount. So I clipped and chewed away with the snippers on this assembly until it sat right. And once I got it to where I liked it, then I hot glued it like he did, and everything appears to be working just fine. Let me take a moment here and make a comment about my strings in my ribbon cable that I use for my sensors on the fingertips. He gives you a dimension, you know, cut these strings so long. I forgot how many centimeters he said cut it, but I'm sure it's long enough. I didn't bother to do that. I stretched the string out the length of my arms and clipped it. It gave me a nice, good long lead so that I had plenty of string hanging out the fingertip side, and I had plenty of string hanging out on the servo end. And I didn't have to worry about length, because you cut it off when you don't need it, right? So I did that, and on my ribbon cable, I bought a 4-foot section of it, and I didn't bother to cut it. I just started feeding it through, and I thought, I'll just, you know, once I get it in, kind of get it all adjusted, I'll pull it back out. Well, once I assembled this wrist, that this ribbon cable got taut and I could not pull it back through, so I'll have wasted a little bit of cable. Just to let you know, if you're going to do that, you may want to be a little bit more conservative or buy more ribbon cable. I'll go back and buy another piece. I locally sourced that. I won't have to wait for shipping. So that was an issue that I had, where that wouldn't fit right, but that was my workaround. On this gear assembly here, he recommends, he actually provides 2 parts, right? This smaller part and a larger gear that has this black section, all incorporated as one piece. The recommendation is to use this smaller gear and to cut off this servo attachment. It's one of the pieces that come with the servo, and just cut it off, and they screwed it on from the top. But I got to tell you, I'm not that good. That's an awful small area to try to get 2 screws down through there. I'm glad they succeeded at it, but I sure wasn't gonna try, not with my tremor and problems. I didn't even try. I just shaped it all up and super glued it on. And the secret, of course, is getting the hole alignment so that the gear is centered and you don't end up with an eccentric wobbly gear. Right? And the way I did that was I took a 3.5 millimeter drill bit and I passed it through from the black piece. Well, actually, I laid the white gear face down on the surface. I ran a little bead of super glue on it, took the black piece, ran it up onto the 3.5 millimeter drill bit, and then dropped that drill bit down into the hole of the white gear. Now, it doesn't actually go into the white gear, it's too big, but it sits and centers itself on that hole, and then I just let that black piece slide down and set in place. I pulled that drill bit out pretty quick so it didn't get super glued, and then put a little pressure on that black piece until that super glue adhered, and I got a pretty well centered gear that way. So maybe that's something that you guys might incorporate. You might find a useful little tip. I hope so. Here we go. Here's the picture I was going to point out to you. This is my servo assembly, right? See how my strings are nice and taut? Okay. I was telling you I didn't use his pulleys. I went on Thingiverse, and one of the guys made these modified pulley gears. It's got a larger one and a smaller one. And I'll put links to this in my comments down below so that you can get to all this stuff. So the way this works is the string, or the tendon as they like to call it, that closes the finger goes on the large gear, and the tendon or string that releases the finger goes onto the smaller gear. That gets rid of that slack and slack problem that you have in the fingers when they're moving. And it worked out nice. Now, another thing that I did that was different, and I'm breaking the rules, if you want to say. He tells you when you put your servos in, run them all to the 0 degree setting, which puts these alignment holes right over here. They should have all been over here. Okay. Well, when I ran all my strings, the string that closes the finger came out on all these sides here, and it didn't seem to want to lay naturally around all this stuff. So I went to my Arduino and I ran all my servos around to the 90 degree position, and I picked up the pulley and I moved it, and I aligned everything on the 90 degrees, and my strings laid in nice. So I just liked the way it worked out. So that's the way I did it. So how am I going to overcome that problem? Well, I played with my robot lab just enough that I now know that you can invert the servo action. So for at least this side, the right hand side, when I go into my robot lab and set this up, I will invert my servo actions, and it will act just as normal as if I had aligned everything at the 0 point. So no problem there. Another thing I want to point out to you here, see, I've labeled each one of these servos, 2, 3, 4, 5, and 6. And that's the pin number. That's the Arduino pin number that servo is hooked to. So that when I'm working and troubleshooting and stuff, I see what servo I'm working on, at a glance. My ribbon cable that came in from my fingertip sensors, I ran it down. You can see here I super glued a little spot right here to hold it flat in the bottom, and then I brought it up and bent it, ran it between my two servos here. I super glued it here and I super glued it here, and I flexed it around and ran it out the hole. On the end of my servo leads, since these are actually going to be in the bicep and I won't be able to see the top of my servo motors and associate it to the right lead, I also just labeled my little leads, right, with what pin number they belong on, so that when I hook them up to the Arduino, I know I'm putting them in the right place. And here's what I'm talking about. You won't be able to see them right here. Here's where your bicep will join to the forearm. So you pass your servo leads out here, and I passed the ribbon cable out to the upper hole and ran one last bead of hot glue right here to hold it, so that that ribbon cable is nice and secure as it passes around my servos, and I don't have to worry about it interfering with the operation of the tendons. Now, being the smart aleck that I am, when it was time to run my ribbon cable for the sensor electrodes, right here, he tells you there's 3 rows of holes. Okay, I'm sorry, right over here on the hand, he says there's 3 rows of holes, and the center hole is where he passes the electrical wires through, and he passes the tendons to the top hole and the bottom hole. Well, I looked at this plate over here, and he's got tendons in this line of holes, and tendons in this line of holes, and then through this slot he passed the electrical conductors. So I played with the hand a little bit, and I looked, and the holes for the electrical conductors and the this row of tendons, they come out at the same point. So I thought, well, let's be neater. Why not just run the electrical conductors in that bottom hole? Everything then is nice and straight and flat coming through, you know, just trying to be cool, I guess. So I did all that, and then when I got out here and started trying to flex my fingers, things didn't work too well. And so I pulled everything back, and I did it the way he suggested. I ran the electrical wires through the center holes and the tendons to the top and the bottom holes, and then re-pulled all my strings. And when I did, I got much better behavior or motion, freedom of motion on my fingers. So just to let you know, I did that. When I got to this point, I split those pairs in, you know, I peeled them back, and then I passed one under and one over, just like you do your tendon cords, right? And I ran them through my fingers. So I wanted to point that out. It's the way I did it. And you do have to be careful. It's real easy to twist all the wires in the tendon cord as you're running through. You got to minimize that. If you start getting twist, believe me, they lock up, they pull against each other, and you lose your freedom of motion. Another thing I did before I put any strings or anything through this hand, I totally assembled the hand and checked out the freedom of motion of my fingers and these joints here, okay? And And I found out, I was lucky I did, because these pieces right here didn't flex down as far as I thought they should. And in one of the tutorials, I don't remember which one, he talked about, yeah, when you're putting this hand together, if you're not getting the flex you want out of these two pieces, then you go in here with a file and you file these stops until it flops down to where you're satisfied, where you like that finger action. And so that's what I did. I kept putting it together and pulling it apart until I got the flop that I wanted. And I knew mechanically that there was nothing binding my hand. Okay, with no wires, no tendons, my hand motion, when I flipped it over, everything flopped down. And when I flipped it over, everything flopped back flat. Okay, so I could do that with my hand, and I had nice, easy, free movement. So I had no mechanical binds. Then I started assembling with the tendons and the wiring. I found that helpful. The bolts that come with the hand assembly are worthless. They're the wrong size. One of them's correct. One of them, I believe it was for the thumb here. Right, this one here you pass in, and it had the little clip that dropped down in here. That one would have worked. The others are, this one didn't have a clip notch in it, and it didn't come with a clip. This one was too short and was a solid end. It had no way to secure it. I followed the bill of material, and I thought I'd bought the 8mm bolts that would be needed for this, but I didn't. I did buy some 8mm bolts, and they're going to be used in other places, but they weren't the ones for the hands. So I went on Thingiverse, and I found these bolts that one of the members made. Nice thread with a nut and everything, and they worked perfect. Excellent job he did. So that was a lifesaver for me. It's prevented me having to stop hunt for parts. I just I stopped, printed these overnight, came back in the morning, everything was fine. And talking about printing, let's talk a minute about how I printed all this stuff. Over here you can see this nice bright white. This is ABS plastic. This is what the majority of people are using to build a robot with. And it is a nice finish. My hand, if you look, is a duller, almost see-through plastic. This is PLA. When I started printing my fingers, which was the first step that I did in this assembly, I started printing my fingers, and as the next set was printing, I was, filing, cleaning up the other ones, cleaning out the holes, running the 3mm and the 3.5mm drill bits through the holes. And as I did that, they broke. They would break off. I'd watched another video when I was doing the little test finger assembly, where you just do the single finger, to prove, hey, everything works. You get your self-confidence. Yeah, I can do this, right? I watched a guy doing his, and he kept breaking those pieces. And he said, make sure you print extra parts, because you're going to break some. Well, based on what he was telling me and my experience, man, I was having bad luck trying to get those drill bits through. When I built my single test finger, I did it with PLA. I had no finger breakage. I ran those drill bits through, simple and easy, no problem. Never even worried about breakage. So based on that, I stopped. I went back to PLA. I printed my whole hand assembly in PLA. with the exception of the cover plates that are gonna, get screwed on top of this. Those are ABS. So they kind of match back in with the arm a little more. But the hand is a PLA assembly, and the forearm is a ABS assembly. Just to let you know that was another little change that I did that you might want to consider. It sure was a lot easier than going through all that breakage and trying to remake parts. Another experience that I had while doing all this was gears in critical areas like that. I found out that there's a way to go into my slicer and change the fill ratio without having to do the whole part. You could go in, so I went in with my slicer and I selected this area in a rectangle, and I'll put that video that shows how to do that. I'll reference it for you. And I did 100% fill on these gear areas, and that will give a lot more strength. And why did I have to do that? Well, when I was trying to get these off the plate, the build plate on the printer, right? I grabbed that gear and I tried to pull it free, pinch that and try to pull that sucker out, and snapped off that gear. So then I went to 80% fill, made another one, and tried to put a screwdriver through this hole here to try to help me pry it off that plate and snap that gear. I went to 100% fill and I had no problem. So I'm sure now that gear will handle any torque that I put on it without any breakage, without losing teeth or anything. So I picked critical areas like that. In here, this area right here, these get flaky and break off. You can make them 100% fill in that immediate area, and you strengthen those without adding a lot of time or material to the print. So that's what I did. I just wanted to point that out to you. In here, if you're going to put the sensors, fingertip sensors in, and of course then you got to run these electrical wires, things change. In the blueprint he tells you, I should say in the tutorial he tells you, okay, if you're going to add your sensors, at this point this is where you're going to add your tips. Okay. When you print out the sensors, you get a couple of pieces that didn't make sense to me, and when I kind of looked at the video, or the pictures I should say, in the tutorial, didn't match up, weren't real clear. So I went on to the forum on the InMoov page. I went to the forum and I did a search, for the fingertips, and it seems other people had that same question, wait, how am I supposed to do this knot? Where am I supposed to hide this knot so I can place these copper plates on and stuff? And there was an answer that put an arrow onto the tutorial picture and said, this is where you do it. Wasn't much help. So I just thought I'd take a little time here to maybe make it more eyeball obvious. This knuckle joint right here, where it's pinned, is a replacement knuckle from the standard finger. And I'll show you the difference here in just a second. But while I've got this picture up, I want you to show that a lot of people are using the 3mm filament to go through and their knuckle joints right here, I went with a brass bar. There was a reason for that. One, I didn't have any 3mm filament laying around, and I wasn't going to buy a spool of 3mm filament that I don't want to use, okay? And so I hunted and I found this 3mm brass real cheap. Found it on Amazon, okay? 10 sticks for $9, I think it was. And it cuts real easy with a nice little jeweler saw, and they go in. And I also like them because they're opposing materials. Instead of being plastic on plastic, I have plastic on brass, and so that does help with the friction a little bit. The different materials don't get the atomic structure bond, and they flop around a lot easier. So that's why I went with brass pins. So now let's get back onto the subject there. I was talking about the wires here. I was going to show you the difference here between this knuckle end and what originally came. This is the original fingertip. This is that last knuckle where the brass pin goes through, and this is its face. Nice flat surface with the two holes where the tendon strings pass through, and you tied the knot, and the knot sat right here on in the middle on that flat surface. And then you put the fingertip over it, right, and you hid that knot. Well, that was fine if you weren't going to do any sensors. But if you're going to do sensors, you need this flat surface to mount those copper plates and to solder the wires on. So this tip wouldn't work. So you don't use that last knuckle. Instead, you use the one that comes with the print when you make your sensor print. And you can see now that is no longer a flat plate. That's cut out with a cavity. And you make your knot, and you pull your knot down into that cavity. Then you mount another flat plate on there where your wires go through, and then you've got, in effect, the same thing you had right here, so that you can continue to build and put the sensor on it. So I hope that helps explain that a little bit. Here's just a little close-up of that cavity with the knot. Now, the size of the knot can be a problem. It's on the thumb, you got a huge hole to hide a nice big knot in. But when you get down to that pinky finger, that cavity gets small again. So a single knot down in there is about all you can get in that cavity. And so in his tutorial, he pointed out that he used a little bit of super glue, and he super glued the end of that knot. And so on all my knots, when I cut them off, then I put a drop of super glue and kind of made sure that knot wasn't going to come free when I get it buried. Because once it's buried, because you got the other plate that's going to go on top of that. One last thing before I bail out on all this, I want to show you what I did with the Arduino Code a little bit. So let's pop that bad boy up, and in the tutorial he gives you a link to the Arduino Code. You can download into an Uno for testing your servos, right? Moving your servos. So I downloaded it and ran into some things that I wanted to customize it a little bit. And so I went back in. Let me go up here to the very top, show you what I did. This is all basically his right here. Didn't change anything there. In the setup, I didn't change anything. Here's the pin assignment, right? and you can see the thumb, the index, the middle finger, the ring finger, and the pinky here. 2, 3, 4, 5, and 6. Remember on my servos I put a 2, 3, 4, 5, and 6. That's what I'm associating with here is the pin number on the Arduino. So just point that out a little bit for you. And of course as I build out, these others will get assigned as well. Then what I did, I added this right here to the setup. I added the serial because I wanted to open up a monitor window and use the monitor window. And you'll see what I did with that. I added two integers here, incoming byte and a select byte. Then when I went into the loop, I added all this right here. Okay. And this is simply cut and paste. I'm kind of lazy. Why reinvent the wheel? So I went on the internet and I said, show me code for serial available, and this little sample code came up. So I copied and pasted it in here. Okay, and of course all I'm doing is saying if there's something coming in from the serial port, capture it, tell me what you got, and remember it by putting it into my integer select. So if there's something coming in, select gets set to something besides the initial value of 77. So I set that value, and then I test for a value. I look at select. If select equals 48, if select equals 57, if select equals 56. Now what's going on here is that the serial port brings in a byte, and it has the ASCII value in that byte. Well, if you look on the ASCII table, you'll find out that the numeral 0 has an ASCII value of 48, 9 has an ASCII value of 57, 8 has a value of 56. So being lazy, I didn't bother to convert, all this from 48 to 0, etc. I just said, hey, if it's a 48, I know it's a 0. So if it's a 0, that means I want to go to the 0 degree setting. So I have it call this function here. And I clear out my select. If it's a 9, I know I want to go to the 90 degree setting. If it's an 8, I know I want to go to 180 degree setting. Right? And again, I'm being lazy here. A 0, a 9, and an 8, I could have put as could have tested for a 0, a 90, and a 180, but then there's a lot more code involved because I have to snatch out three bytes and test for what's in and add them together and to find out if it's a 90 or a 180. So on my serial input I just put a 0, a 9, or an 8, and I know what I'm representing. So I was being lazy. I let one character represent it instead of having to use 3. So I have my 3 functions. I added this all 90 function in. So let's go down here and look. You'll see that I didn't change anything in this all virtual. I left it the same. The only thing I did is I go in here and I comment out what I don't want to use at the moment. So when I was testing my fingers, I didn't want my wrist moving back and forth. I didn't demonstrate for you my wrist, but it's working. So I just commented it out so I could play with my fingers. And when I was working with my wrist, I commented out all my fingers so that I was just moving my wrist and I could see what was going on. So with all that being done, another thing I found out was when I typed in the 0, it went to the 0 position. Okay, and the servo motors for the fingers are only 90-degree movement servos. So at 0 and 90 is full motion. But when I went to 90 in here, because he tells you, you know, to set them at 90 and then set them at 0. Well, what he's really saying is move it to full motion and set it to no motion, right? Because if you go in here and go to a 90, it only moves halfway on that servo and stops, because it seems that the Arduino servo in the library is set up to use a 0 to 180 motion on a servo motor. So by going to 90, you really didn't go where you thought you were going. Okay, so that's why I added that 180 movement, because the 180 moves that servo all the way to the far extreme from 0. You heard it, it sat there and hummed and everything, but I'm not worried about that right now, because when I get into my robot lab, all that will go away, because I'll adjust the minimum maximum settings to get a nice silent movement. So I just wanted to point that out to you, what I did in my code, and I thought it might be something of use. So again, that will be in my folder, my InMoov folder on my OneDrive that I've provided a link to earlier. But since this is a few videos down, I'll probably put that link back into this description as well. So I hope that's meaningful. Maybe you guys will enjoy using it. If not, his works. You just need to know that limitation of the movement. So with that, I'll say goodbye. Have a nice day. I'll probably come back when I get my fingertips moving. My sensors working, I should say. Thank you. Bye-bye.